right, let's crush another chemistry question. This one says, determine the molar concentration HBr in a 48% by mass aqueous HBr solution with a solution density of 150 grams per centimeter cubed. All right, so we don't have any actual values for how much of this we have, and we're looking for concentration, which is a ratio. So we can just kind of make up how much of the substance we have and work with those numbers, apply those numbers to the situation. So if we say we have 100 grams of this solution, it'll give us some context for the problem. So with 100 grams of the solution, we would have 48 grams of HBr because it's 48% by mass. And what would be left over from the 100 grams is 52 grams of H2O. It's 52% water if it's 48% HBr. Those are the only two things in the solution. So concentration is typically given in moles per liter. So we have grams of solution, which is sort of weird. So we should probably just convert that to liters. Centimeters cubed, which is what's given in the density, is the same as liters. Liters are measured in centimeters cubed. That's an equal value. So if we want to calculate the volume of our solution in liters, we can just do 100 grams, which is the amount of solution we have, divided by 1.5 grams per liter, which is the solution density, and that's going to give us 0.06 repeating liters of the solution. And that'll be useful in our unit conversion that we're going to do down here. So now we should just be able to dive into some dimensional analysis to try to get to our moles per liter that we're trying to achieve. So let's start off with our 48 grams of HBr. And again, we want this to be moles per liter, so we should convert our grams into moles, which involves a molar mass calculation, which is going to look something like this. Hydrogen's molar mass is 1 gram per mole, basically. Bromine's is almost 80 grams per mole, and when we add those up, we get this molar mass right here of 80.916 grams per mole. We're going to want to put the grams on the bottom because grams are what we're trying to cancel. So that's 80.916 grams per 1 mole on the top and the bottom. So we're in moles. And again, we want our answer to be in moles per liter. So now we can just introduce our volume that we found earlier, which is 0.06666 repeating liters. Now all we have left to do is calculate, because we got the units we want, which is moles per liter. We just multiply the tops and then divide by the stuff on the bottom. We end up with a molarity of 8.89 moles per liter.